Welcome to Academic Digest tutorial class. Work, energy and power. Question here says a block of mass 4 kg is projected up a rough inclined plane with a speed of 12 meters per second. The plane is 18 meters long and rises to a vertical height of 3 meters. If the frictional force on the block is 2 Newton and g 10 meters per second, find the speed of the block after it has traveled. So what this question is trying to say is that for any inclined plane question that gives you friction, I remember I once told you that whenever you talk about friction, you should be talking about displacement or talking about horizontal axis. While for work, whenever the work talks about gravity, you should be talking about heights, and that is vertical or free fall. So a situation where it combines both friction, gravity, that kind of question requires you to use the formula we call the formula for work, energy, power on an inclined plane, and I will give it to you. There are two formulas, two methods. The first method is the energy method. So method 1, energy method. And the formula to use when it's energy method is just to say initial kinetic energy is equals to final kinetic energy plus potential energy plus work done by friction. Work done by friction. That's the first method. So if we are solving this thing now, let's analyze it. Let's put the diagram out. So solving this is an inclined plane. Now this inclined plane has mass 4 kg. Then it was thrown up like projected with 2 meter, okay, 12 meter per second. The plane 18 meter long, that is from here to here is 18 meter. Rises to a vertical height of 3 meter. Then it's from here to here is 3 meter. Then frictional force. Since this thing is thrown to move this way, so the frictional force will be acting down back. It opposes motion. So frictional force is 2 Newton. And so they gave me G to be 10 meter per second square. So they say find the speed of the block after it has traveled 18 meter. Yes, after it has moved from there is projected on 18 meter. So to solve this question, I want you to snap the question, keep it in mind so that you can have space to solve. So what I'll simply remember is that kinetic energy initial is half mu square. That's for initial. While final is half mv square plus potential energy is mgh. Work done by friction is simply frictional force times displacement. So here, when you're doing the friction, don't go and say friction is negative. For this formula, use the friction given to you. It's in the method 2 that we analyze everything using conceptual methods. So this is going to be half mass is 4. The initial velocity is 12. 1 half 4. We don't know the v, the final speed. That's what we're looking for. Plus m is 4. G is 10. The height is 3. Then plus frictional force is 2. The displacement is 18. So a situation where they give you displacement and give you heights and telling you to find velocity for the speed, this is the formula to use. Or the method 2. I'll still show you the method 2. So this is going to be okay. 2 here 1, 2 here 2. This is 144 times 2 equals to 2 here 1, 2 here 2. 2v square plus 4 times 10 4 times 10 times 3. 120. 120 plus. Is this not 36? 36. So 144 times 2 should be 288. Yes, 288. So it equals to 2v squared plus 120, that is 156. So move over 288 minus 156 equals to 2v squared. So 288 minus 156, 132 equals to 2v squared. Divide both sides by 2. So 132 divided by 2, 66. So to make v subject of a formula, take square root of both sides. So v is equals to square root of 66 is equals to 8.1240. V is approximately 8 meters per second. So this is it, the energy method. But assuming I want to use the second method, which I call it the force acceleration kinematics, force acceleration, force, or you say force acceleration, okay, kinematics. That's force acceleration kinematics method. They refer to this in so many names, but I call it forces on an inclined, using forces on an inclined plane, or the force acceleration method. So if I'm using this, what I'll do is to first step 1. If I'm using the second method, that is method 2. I hope it will give me space. I just want to do it here because of the space. Method 2. What I would simply do is to say, since this body is thrown up, there is no pulling force, it's just thrown up. Because it's thrown up, there are forces that want it to come back down. The first one on an inclined plane is the x-axis. That is the axis that wants something to slide, which is mg sine theta. And the frictional force itself, they are going this way. So the total force here is simply frictional force plus x equals to the total force F net. And frictional force is given as 2 Newton plus mg sine theta. X is mg sine theta. What's the total force? So let's get sine theta. Sine theta is equals to y over x, or you say opposite over hypo. So what's the opposite? If this is the angle, the opposite here is 3 over the x hypotenuse is 18. Remember, 3, 18, this whole sine. So if I know that 18, so sine theta is equals to 3 over 18. So let's do 3 over 18 is equals to 0.1667 sine theta equals to this. So I'll just come here and do 2 Newton plus 4 for mass, 10 for gravity. Sine theta is simply 0.1667 equals to the total force. Let's punch that. I'm fast. Trying to be fast. 2 times 4. Okay, sorry. So let's do the times first. 4 times 10 times 0.1667. So I have 6.668 equals to F. So plus 2. So I have 2 plus 6.668. I have 8.668 equals to the total force. F net equals to this. So now that I've gotten the force, the next thing is to ask myself, this force, notice that as this thing is thrown up, the velocity is thrown up. The next thing, as it's moving up, the forces are dragging it down. So what I have on this inclined plane is actually not acceleration but retardation. It is going to be sliding back. So I'll have from F equals to ME. What I have here is minus E. So this is going to be making a sort of the formula. I have minus E equals to F over M. So E, to get the acceleration now, will be removing the minus F over M. So that you see that force we got, the force we got is 8.6. So this is going to be equals to minus 8.668 all over the mass, which is 4. So 8.668 divided by 4. So I have A to be equals to minus 2.167. The minute you forget that what you have is actually retardation, because this movement here, the change in velocity, acceleration is change in velocity, and the change in velocity on this object is actually in a form whereby instead of moving up, it will have to be coming back down. So the change in velocity is backwards. So that's retardation. So using it, the force here is equals to negative, that is M negative A. So that is what we did. If you forget this thing, you will fail this question. So that now that we've gotten this, we can now go back and ask ourselves, what are the things we have now? We have A. So I can use any of the equations of motion, but the one that works it fastest is this one, which is V square equals to U square plus 2AS. So that is why I called it the force acceleration kinematics method. That is the FAK. So the FAK method, FAK, the FAK method. If you like, say it's fake. So you know. So I'm calculating the final speed, and this method is actually the best because it helps you in a situation where they ask you to find the force here. You can just stop here. They ask you to find the acceleration, you can just stop here. So since it's the velocity, the final speed we are asked to find, I'll just do v square equals to, the initial velocity is 12. Read that question, you see 12. So 12 square plus 2. Acceleration is here minus 2.167. Why the displacement of this is simply 18. If you look at that question. So this becomes 144. Sorry, this is negative. This will be negative. So I'm going to be having negative 2.167 times 2 times 18. So I have minus 78.012. So V square equals to, so by the time you do 144 minus 78.012, you are having V square equals to 65.988. So let me continue it here. So if you do, to make V sort of formula, you do V square, take the square root of both sides, root 65.988. So this will cancel this. So V is going to be equal to square root 65.988. We're going to be having 8.1234. 123 approximately 337. So V is approximately 8 meters per second. So it's the same thing with what we got in the first one. So there you have it. Whenever you are given friction, see the best way to note it. Whenever a question of work, energy or power, talks about, first of all, talks about on an inclined plane, then height is given, displacement also given. That means that they expect you to know that G will be there. G for the height, friction for displacement. In this kind of case, you use, if it's final speed they ask you to find, you can easily use the energy method to solve it. But in a situation where they ask you to find the force, the acceleration, and or the speed, then analyzing it using the FAK method will be better. But the fastest is the energy method. So thank you, and do subscribe to my channel. Remember, I said that whenever it has to do with work done, that whenever a body is talking about climbing hill or moving up anything, you have it in mind that you're not relating the displacement. You don't have anything to do with the displacement unless it has to do with the inclined plane. While if a body talks about friction, you are looking at the displacement and not the height. So that's why I normally say that friction is to the horizontal, or is to displacement what gravity is to the vertical, or you say what gravity is to height. Thank you. Subscribe.